All right, scholars, we are working today on lesson 3 from unit 9. So a lot of you go lesson 9.3 because we're used to doing that. This one's a little bit different. This is for the area of regular polygons. Guys, what's the definition for a regular polygon? What is a regular polygon? What makes a regular polygon? If you don't know, this is going to hurt you on your standardized test. Oh, wait, on this test. Okay, guys, what's a regular polygon? Yes, ma'am. Well, how about a polygon is a polygon? How about that? Okay, a polygon. That's what?
That has all the same sides.
Oh, all the sides are congruent. That's a good start. Keep going.
And all the angles are.
Yeah, isn't it equilateral and equiangular? Guys, that's all you have to remember. A regular polygon is an equilateral and equiangular polygon. Now, again, how many times have I told you guys to go back and look over chapter 6 in the last 2 weeks? At least 4. What does that tell me that you guys have not done in the last 2 weeks? Looked over chapter 6. Guys, chapter 6 is really critical. That's the quadrilateral ones, and that's the stuff talking about polygons. You need to know what a definition of a regular polygon is, or this doesn't matter. What I'm teaching today wouldn't matter because when you see it, you wouldn't know what to do because you wouldn't know the words. So make sure you know what a regular polygon is, all right? And obviously, look down below. We have our polygon FGHDE. You can see that literally all the sides here are going to be congruent to each other. And it's drawn, aren't all the interior angles the same way? Now, obviously, I have other things drawn into my polygon, but it's very easy to see. It's very symmetric. I call it the pretty looking ones. By the way, what's a quadrilateral that's a regular polygon? Square. What's a triangle that's a regular polygon? Yeah, equilateral triangle. We use them all the time, so make sure you know these. All right, now there's some different things that you need to know about these figures when we're working with it. First of all, a regular polygon can actually have what's called a radius. Now, when we think of a radius, we think of a circle, correct? All right, now a radius, though, is literally a segment from, oh wait, we have to go from the center of it. So do we still have a center? Yep, smack dab in the middle. But I want to do this, you don't have to. But notice, look at this. If I draw in a circle here, I know we haven't talked officially about circles, but aren't those the radius of that pentagon that you see right there? Isn't it also the radius of the circle? So basically, that's called, and remember we used this term way back first semester, that's an inscribed polygon, and the circle circumscribes it. They share a radius. So that's why they use the word radius to describe that. But here's the easiest thing. The radius just goes from the center of your polygon to one of the vertices. Pretty easy. And when you're doing that, what type of triangles do you end up forming? What type of triangles do you see those? Isosceles, correct? So you're going to have isosceles triangles that you're going to be working with, so that's important to know. We also have a new term that you haven't seen before, so I want to make sure that you get this one down. It's called the apothem. All right, so what is the apothem here? Well, the apothem is the distance from the center to the midpoint of one of the sides, okay? So it's that line segment. Basically, we call that the perpendicular bisector before. And so every one of the triangles, I could draw that in. It'd be the same thing. Like I could draw it here, exactly the same idea. And of course, guess what letter you use for apothem? An A. Earth-shattering, I know. Also, we have another term that we call the central angle. Let me guess, where do you think a central angle is going to be located? The center, right? In the central area, right? Well, that means its vertex is going to be on the center, but its sides of the angle are going to be the two radii. Remember, radii is the plural of radius. So really, like for instance here, let's just write these down. You'll have a lot of central angles on here. All right, so our central angles would be, let's go this one. Let's go angle HCD. Guys, is there another central angle that you can see? Yeah, GCH, so angle GCH. All right, there should be more. What's another one? Yep, FCG. What's another one? Remember, it's formed with the two radii. Don't let an apothem throw you off. Yeah, FCE. So angle FCE, and there should be one more. Angle what? ECD. Guys, how many sides does a pentagon have? 5, right? How many central angles did you just write? Are you starting to see a pattern here? All right, look at the radii drawn. How many radii are drawn? 5. See patterns, anyone? Like, you know you're doing this right if you have 5. If you came up with 6, something went wrong, all right? We have only 5 sides to work with. Now, what do you think is going to be so special about every one of these central angles? Yeah, they're going to be congruent to each other, especially because it's a regular polygon. And so you need to know the measure, how to find those. Well, that's really easy, guys. All the way, one single point, how many degrees is all the way around it? 360. So to find the measure of one central angle, it's just 360 divided by the number of sides. So it's 360 divided by the number of sides. Now, looking at this diagram, we should be able to find some other things too. Like, for instance, what would be considered a radius in this diagram? Let's do those in green here. Is CH a radius? Yeah, so we have segment CH, we have segment CD, we have segment CE, segment FC, and my phone is going off, and segment GC. I'm going to shut it off. Or it goes off on its own, so I don't have to shut it off, so that makes it even better. Okay. Now, guys, what's going to be so special about all of those? They're going to have to be what? Congruent to each other. So remember, the radii are going to be congruent in this case. Now, we also have just one apothem that we have drawn, and that's just segment BC. But here's the key thing you need to remember, and I'm going to see if I can do it in a bright color here. Let's go orange. Just remember, your apothem will always bisect your side every single time. And when you do that, do you guys see any right triangles being formed? So we're probably going to be using that. All right, I think now there's one other term that this is my term. This is not a term from the book, so just know that. I call what's called a central angle triangle. And the key thing is, if you draw this, you don't even have to draw out the whole diagram. A central angle triangle is a triangle that's formed with obviously the central angle on one of the sides. And so the example here I would use would be like triangle FCE. And the reason why I use that one as my central angle triangle, but again, guys, there's 5 of those. You could draw any that you want. It's just the fact that the apothem is drawn in that one. And so I'm going to use that knowledge that I'm making isosceles triangles. I know that if I draw the apothem, it bisects the base in order to help me calculate the area of a regular polygon. Now, what is the formula for the area of a regular polygon? Now, here's one way you could calculate it and you would always get it right. Find the area of one central angle triangle and then multiply by the number of triangles that they are. Or use the fact that there's a formula that's already does all that for you and get it done quicker. So this following one is A stands for the apothem, nothing really cool about that. And P stands for the perimeter of the polygon. So remember, P equals perimeter of polygon. All right, so the formula is area equals, and you can write how you want to. I go apothem times perimeter over 2. Or, of course, there's always someone that goes 1/2 apothem times perimeter. Now, here's the one thing you need to remember. How do you find perimeter of something? Add up the sides, right? Well, if n is the number of sides and s is the side length, so you can even put s right there if you wanted to for side length, it's just n times s. So we're going to do a lot of the perimeter. And the nice thing is that works anytime that you have, again, that has to be for a regular polygon in order for that to be true. All right, guys, we're going to do some setup problems, then we're just going to crank them out real quick. The 3 main figures that we're going to use with this, but not always, but we're going to use with this is going to be an equilateral triangle, a square, and a hexagon. This is mostly important for hexagons. Okay, let me reiterate that. You really need to know how to do this for hexagons. So make sure that today, learn the other 2, but focus mainly on just the hexagons is what's going to make or break you in the next chapter after spring break. All right, so First things first, it says find the values of the variables for each regular hexagon. All right, so looking at this, what do I know? It's a regular hexagon, but what's one piece of information they absolutely gave us already? They gave us the radius, right? They gave us the 8. So we know the radius is equal to 8, but you notice they didn't draw it in a very nice place. I'm going to draw it in order to make, and I think you guys will go with me on this. Can you see this central angle triangle I'm highlighting right there? So it makes it so much easier for me to work with. Now, so that's my radius, and I'm going to put there's an 8 here and an 8 here. Now, looking at that, I want to find Q, you know, this is my side length. I want to find X degrees, which is half of my central angle, and I want to find P, which is really my apothem. So the first thing, what would you have to do? Well, you always have to find your central angle measure. And so all you do is go 360 divided by 6. Oh, look, a number that we've seen that's very familiar. What is it? 60 degrees. But what does your apothem do to it? So from here to here is 60. So let me even redraw that to make it a little bit bigger so you guys can see it. That's 60. But what does the apothem do? The dashed line right there. Bisects it. So really, oh, look at that. It bisects it. So that becomes 30. This becomes 30. Oh, wait. Do we just create 30, 60, 90 triangles? Oh, it's just amazing how this stuff just comes back all the time, isn't it? And I know this side, and before I do anything else, I know that side's 8. Can I start using what I know about 30, 60, 90 triangles to solve for parts? What's the short leg? 4. If that's 4, doesn't that make this one 4? Oh, wait, what is your side length? 8, right? So what does Q equal? 8. All right, I want to get to my apothem. How do I go from short leg to apothem? Multiplied by root 3, so that's 4 root 3. So P is equal to 4 root 3. Guys, what was X degrees here? That was 30, right? Because we knew that we bisected our central angle. You see how you just have to go like, 30, 69 triangle is going to be a key on this one? All right, now let's look at the next one. They gave us a hexagon again. What parts of the hexagon did they tell us? What's the one thing I know? The 4, which is my what? That's not my radius. A radius has to go to a vertex. That's your apothem. Now I'm looking at it. I'm looking to find my radius. But what's the one thing I can find very quickly? Can I find A real quickly? Because isn't that my central angle? So that's going to be 360 divided by 6. Oh, that's 60 degrees. So nothing really changed from our last problem. But you know what? I'm going to redraw my apothem here, which bisects that. So I get a 30, 60, what? 90. Now I'm going to put my 4 down because all the apothems would have to be the same. But what part of that triangle is that? The short leg, the long leg? Which one is it? The long leg. I need to get to the short leg. How do I go from long to short? What do I have to do? No. Divide by, I heard 2 different answers. Which one is it? Divide by what? Root 3. It's a long leg to short leg, so it's divided by root 3. Oh, look, I have to rationalize the denominator. So that's 4 root 3 over 3, and that's just half, my friends. So to get to D, do I need to double it? 4 root 3 over 3. I get 8 root 3 over 3. So, I mean, those are all 4 root 3 over 3. Guys, how do I get to the hypotenuse? So I go times 2. So, oh, look, 8 root 3 over 3. Do you notice on a hexagon, your central angle triangle is actually an equilateral triangle? But that works only for a regular hexagon. Unfortunately, not the other ones that we're going to work with. All right, let's see if we can keep going with these and see if we got a good pattern here. Oh, look, it says for each regular polygon has a radii and apothem as shown. Find the measure of each numbered angle. All right, first things first, you always solve for your central angle first. So guys, your central angle, which by the way is angle 4, what's it going to be? Yeah, it's 360 over 4, which is 90 degrees. So that's 90 degrees. Okay, but what does the apothem do to our central angle? bisects it. So guys, isn't that 45 and 45? So the measure of angle 1 is going to be 45 degrees. Because remember, the apothem bisects my central angle. What else do I know? Yeah, the measure of angle 2 is also what? 45. Oh, what's the measure of angle 3? 90. So if you work with a square, would a 45, 45, 90 triangle be a better choice? Yeah. Oh, now we have our equilateral triangle. So you need to know your central angle again. Well, the easiest one to solve for is 7 because it's drawn separately, but it's still part of it, and we need to remember it will be bisected. So the measure of angle 7, which is your central angle, is 360 divided by 3. That's how many degrees? 120? So guys, what's the measure of angle 5 then? 60 degrees. Well, then that makes 6 to be what? A little bit different look of a 30, 60, 90. A lot of people mess it up on the equilateral triangle. Just know that. Be very careful where you put your 60 and your 30. Don't put it in the wrong location or it will be completely wrong. But guys, if you can do those things, solving for sides or solving for 30, 60, 90, 45, 49 triangles, you're going to be able to do today's stuff pretty well. So let's just start working on the problems, okay? Start working this out. It says find the area of a regular hexagon with a side length of 6 centimeters. Now, if you're really good at drawing, you can go ahead and draw the regular hexagon. Go for it. I'm horrible. I'm going to draw the central angle triangle. Because when I do that, I know the following things. I have my radius. Guess what's drawn in here? My apothem, right? And this would be my side length. So I'm going to put in what I know. Guys, what do I know? The side length is what? 6. But what does my apothem do to it? Bisect, so I know that will be 3. What's the other piece of information I told you that you had to know? You always have to know your central angle triangle. So you always calculate it. So the central angle triangle is 360 divided by 6. Oh, that's 60 degrees. So remember, from there to there is 60 degrees. So half of that's going to be 30 and 30. All right. Now, before I go any further, let's think about what we're actually solving for a moment. I'm looking for the area of a regular hexagon. Well, my formula is apothem times perimeter over 2. Could I find either one of those right now, apothem or perimeter? Which one are you going to solve for first, guys? The perimeter? Okay. So my perimeter is n times the side length, right? Well, how many sides does a hexagon have? So I get 6 times 6. Well, isn't that 36? Now, I still need my apothem. Can I use my diagram to do the apothem? Yeah, what am I going to multiply by? Because it's short leg to long leg, so it's multiply by root 3. Guys, do I have everything I need to plug into my formula? Notice, the rule for writing down the formula, has it changed? Do I still have to write it? Put my work directly below. So my apothem is 3 root 3. My perimeter is 36 all over 2. So guys, when I work with this, I got 36 divided by 2. That's 18 times 3. That's 54 root 3 square centimeters. Does this take a little more time than what we've been doing? But it's not impossible. All right, I'm going to move that one up, and I'm going to start reading the next one. It says, find the area of a regular hexagon with an apothem of 5 root 3 meters. All right, again, if you are really good at drawing out a beautiful hexagon, go for it. I am not going to stop you. But I'm just going to take the time and draw my central angle triangle. Here's my radius. My radius, didn't they tell us our apothem this time is 5 root 3? So I'm going to put it in. You can even write off to the right of this, you know, your apothem times perimeter over 2, so you know what formula you're looking at, you know what you need. Well, the cool thing is I know my apothem, I just need to find my perimeter. But to do that, guess what I still have to solve for first? my central angle. So we got 360 divided by 6. Oh, that's 60 degrees. I have a feeling you're going to start seeing a pattern pretty quickly here. So what does the apothem do to your central angle, guys? Yep, bisects it. So I know this is both 30 and 30. So this would be 60 and 60. Oh, look. Can I use this to solve for my side length? What side of that 30-60 triangle do I know? Long leg. How do you get to short leg? Divide by root 3. So this is 5. All right, guys, what is the length of your side? 10. All right, so let's get our perimeter. The number of sides, well, a hexagon has 6, so 6 times 10. I get that to be 60. We already have your apothem. Let's plug it into our formula. Our apothem is 5 root 3 times my perimeter of 60 all over 2. I get 150 root 3 square meters. The root 3 comes along. Guys, one thing that I noticed commonly on the quiz, people would have a radical 3 in the problem and they would drop it for their final answer and get it wrong. Like they would have all the work perfect. All of a sudden there was a root 3 in the problem, it disappeared. And I'd be like circling it, going, put in arrows, like, bring it down, because you don't want to get it wrong. All right, now this one says find the area of a square with radius 7 centimeters. Now, guys, when you draw this out, I want you to know a square is pretty versatile, correct? We know a lot about a square. We know it's a parallelogram, we know it's a rhombus, we know it's a rectangle. Look at me right now. Do not use apothem times perimeter over 2 to find the area of a square. Don't waste your time. Don't do it. Because if you're given the radius, do you know the length of the whole diagonal? What's the whole diagonal's length, guys? 14. Do we have any formulas about the diagonals that could be used? Yeah, don't you guys agree I can use diagonal 1 times diagonal 2 all over 2? Because a square is also a rhombus, so in this case, do not waste your time and go 1/2 apothem times perimeter. All you have to do is know the diagonal length, which you told me is 14 for one of them. What's the length of the other one? 14. They don't change, right? Because a square is also a rectangle, so they're congruent. All over 2. So that's 196 divided by 2. I do believe that's 98 square centimeters. So, even though I just introduced to you a brand new formula, do you think it's the best one to use? Not always. Do the one that's easy. Now, could I do one with that? Yes. But guess what? I'd have to use a root 2 in there. It meant 7 root 2 over 2, then you have to double it, and then you get the side. Why do we do that to ourselves, right? If we can go quicker and easy, go for the best way. But notice, did I write down my formula? Those of you who are very good at writing down your formulas and figuring out, you do much better. Those of you who freehand it, it's not quite so good for you. All right, let's look at another one. It says find the area of a regular triangle with an apothem of 4 inches. So here's our diagram. I'm going to draw this one out. I can draw triangles better than hexagons. Now, they said apothem of 4 inches. So from here to here is 4 inches. Now, the problem with this, I don't know the height, I don't know the base. You could use what we're using to get that, or could I use the formula that we have, because it's a regular polygon, could I still go apothem times perimeter over 2? Could you use side squared root 3 over 4? As long as you know your side, yes you could. There's a lot of options for you on this one. I'm going to use the regular polygon approach just so you guys get in the habit of thinking of it this way a little bit. So I'm going to draw in my central angle triangle. Remember, that's this whole triangle is a central angle triangle for an equilateral triangle. We need to remember the side is going to be bisected, so this would be our side length. Our central angle, how we find it is the same. It's just 360 this time divided by what? 3. So it's 120 degrees. Oh, wait. From here to here is 120, so that means this is 60. This is 30, correct? So what side of that 30, 60, 90 triangle do you know? Long or short? Short, right? I need to get to which one? long leg. Notice I never have to solve for the radius unless they give me the radius first. You don't have to do that. So that's 4 root 3. Well, that's 4 root 3. So what's the whole side length? Don't multiply it. Yes.
Will a regular triangle always make 30, 60, 90 like triangles? Like
Yeah, because the central angle is always going to be 120. Kind of like a hexagon is always going to make the same type 30, 69 triangles that you always see. But notice the difference between the two. Look where your 30 and 60s are on the regular triangle, and look on your, because remember, this is supposed to be our hexagon. Yay, right there. Oops, didn't mean to do that. That's a first. I've never done that before. Oh, I feel so smart for knowing how to use that with the mouse. All right, anyway. But that's basically what the hexagon would look like. You see why I don't draw my hexagons? I only do the central angle triangles. There's a major reason why. So you got to be very careful with those. All right, let's finish this, and then I'll let you ask a few more questions. All right, so perimeter on this one. We get 24 root 3. So our apothem is 4. Our perimeter is 24 root 3 all over 2. Well, 4 divided by 2 is 2. 2 times 24 gives us 48 root 3 square inches. All right. Emma, you had a question.
Maybe base times height. Just do 8 root 3 times 8.
You said 8 root 3 times 8 base time height? No, your height, remember you'd have to calculate, would be like this. Your height is actually 12 and your base is 8 root 3.
Is that possible?
Because your apothem have to be part of your height, right?
I thought the apothem was. Oh wait.
The apothem does say the
radius.
same.
Oh, okay.
Yeah. So you have to remember, this is if they only give you apothem, that's why it's sometimes easier to just use apothem times perimeter 2. But notice, I could redo this. Can I use side squared root 3 over 4 for this? My side squared just ends up being 8 what? Root 3. I mean, you have options. So the nice thing about equilateral triangle, you just start marking things up. Now this one, a little bit different. It says find the area of the equilateral triangle with the given radius. So here's my radius. You think I'm going to use my central angle triangle probably again? Yeah. I'm looking for my side. Don't know it. What's your central angle on this one, guys? Yeah, 120. So we know that's going to be the case. So again, I need to make sure I put my 60-degree angles in the right spot so they add up to 120. But I need to know side length. Well, you're given the hypotenuse this time. What's your short leg? 2. Does that give you your apothem, guys? Yeah, your apothem is 2. To get to the long leg, you're going to have to multiply by root 3, so that's 2 root 3. So my side length, that's 2 root 3 plus 2 root 3, is 4 root 3. Great, so I know my apothem. My perimeter is just going to be n times s. Well, n is 3 this time. My side length is 4 root 3. So it's 12 root 3. Now, our formula is apothem times perimeter over 2. Our apothem is 2. Our perimeter is, 12 root 3. I about wrote the wrong thing down. 12 root 3 all over 2. I got this to be 12 root 3 square units. All right, now, those of you who don't see this as well, could you do this thing? Use the triangles like we did, but could you make this whole thing your height? Could you do that? What would be your whole height then? H would have to equal 6. Is my side now my base? Could I do it this way? Area equals base times height over 2. My base is still 4 root 3. My height this time is 6 all over 2. Hey guys, did I still get 12 root 3? Do you see how there's just a lot of different options you could use with this? Just be right. Give me your formula and be right. I know that sounds way probably too much like you should do it one way. I'm not going to tell you that. Kind of like with a square. There's more than one way of doing a square. Right. Use the correct formula. Show me your work. You're going to be fine. All right. Now, what if you have something kind of nasty like this? Well, here's the nice thing. If they give you the apothem and the side length, can I just plug and chug into my formulas? So this is where your calculator is great. Now, I'm going to tell you right now, I on purpose gave you one that you can't do this, and you have to use angles and trigonometry on for you on one of your homework problems. It's just the last problem, so it's just one. But with this one, it should be very easy. Long as you recognize what you have, it's pretty simple. On this first one, guys, what's your apothem? 6 inches. What's your side length? 5. Do I have everything I need to solve for the area of this? Yeah, because remember my area formula is apothem times perimeter over 2. Well, your apothem is 6. What's your perimeter on this one? Isn't it 40? Isn't it 8 times 5, guys? That's 40 inches. So now I have to just plug it in. 6 times 40 all over 2. Notice I don't want to do a central angle triangle on this if I can help it, just because it's not going to be a 30, 60, 90 triangle or 45, 45, 90 triangle. I got that to be 120. What'd you guys get? Again, write your formula. Work directly below. Label your final answer. Guys, look at me one more time, please. I know I'm being very insistent. The people who do this consistently were the ones who scored really well on their quiz. People who were not consistent on homeworks with writing down their formulas, their work directly below, it happened on their quiz and their quizzes fell apart. Or they missed problems they should have gotten right. So just be careful, because remember, when I grade this, do I grade for the 1 point for just the formula itself? Several people forgot to put formulas down. The second part that I grade is I grade for what you're plugging into your formula. If you don't show that to me, I don't give you the points. Are you with me? Of course, then you get a point for your answer. And I take off if there's not a label. So make sure you're being very careful with this stuff, guys. All right, let's look at the next one. Do we know the apothem again? Yes, so there's our apothem. Can I find the perimeter? How many sides does that have? What is it? 9, isn't it? So 9 times 4.7, what did you get? 42.3. All right, so let's put it in our formula. We have our apothem times perimeter over 2. Our apothem is 6.5. Our perimeter is 42.3 all over 2. Now, our answer key said find the area of each regular polygon to the nearest square inch. So once you plug that in, I think my decimal looked something like this. So was it to the nearest inch? (137 square inches). Guys, think you can survive today? What's going to be the key? Draw your what? Yeah, draw your, here's the thing, draw your central angle triangle. If you've drawn your apothem and your side length, just mark it up carefully. You guys are going to be fine. Does that make sense? All right. Also, guys, I would sit there